Hello and welcome to another episode of Maths with Mrs. Banks, where we make maths fun and easy to learn. And in this video, we're going to focus on Mathematics Grade 11 Financial Mathematics. And this question comes from the November 2024 Eastern Cape paper. And that was question 8. Question 8.1, we start. A Google Chromebook costs 14,500 and depreciates by 13% per annum, compounded annually, calculated on the reducing balance method. Now, the reducing balance method is another way of saying compound decrease. So this is a compound decrease equation or question, if I may say. So this is compound decrease. And I'm going to show you how to annotate a question like this so you have an idea of what it is that you need to do. Now, the question says, calculate what a Google Chromebook will be worth after exactly 5 years. So this is the number of years n, and the question that you are supposed to answer is the worth of the book after 5 years. So that is the final amount, you A. That is what you're supposed to find. Now we know that we're dealing with compound decrease. We're looking to find what the value is after 5 years. Now, what is the rest of the information? Here is your depreciation rate. Remember, we're dealing with the reducing balance method, meaning that it's compound decrease. So this is the interest rate, the depreciation rate, and this is the amount that you start with, your initial amount. So that is your big P. And we are told that this is done compounded annually. So meaning that there are no funny ways you are calculating with this type of interest, because your small p or m or whatever other you want to use is 1. That's your small m or p. Calculate what a Google Chromebook will be worth after exactly 5 years. So let's get down to it. 8.1. So we're calculating the final amount. 8.1. The final amount is what we're calculating, in the equation that we'll be using, the reducing balance method, is a compound depreciation equation. N equals to 5 years, right? The initial amount is 14,500 and the interest rate is 13% per annum. The interest rate is 13% per annum, which is translated to 0.13. Always make sure that you write your interest rates in decimal format for as long as and as whenever needed. Now let's find the final amount. A equals to, that is 14,500 in bracket 1 minus 0.13, all to the power of 5. Take out your calculator. This is how you calculate it. So that will be 14,500 in bracket 1 minus 0.13. Please make sure that you are careful with that, because it's very easy to put a plus in front of that. Okay, you must to the power of 5. It's very easy to put a plus in front instead of a minus in that formula, and that will give you 7,227 and 10 cents. 7227, comma 12. Therefore, always answer the question. Therefore, the Chromebook will be worth, it will be worth 7,227 and 10 cents after 10 years. Is it after? No, after 5 years, sorry. After 5 years. And that is your answer. Next question, 8.2. Let's go back to the question. Because it deposits 15,000 rand into a bank account for a period of 10 years. This interest rate for the first 4 years is 6% per annum, compounded monthly. For the next 6 years, the interest rate changes to 10% per annum, compounded semi-annually. Now, this is a timeline sort of type of question, and we're going to draw this timeline so you have an idea of what it is that you're working with. Next, the question goes 8.2.1. Convert the nominal rate to annual effective rates. Answer must be left correct to 4 decimal places. That's basically what you must leave your interest rates in. In general, it makes life so much easier to convert to whatever format, including percent format. Right, first, before we do that, let's convert this into a timeline. So we deposit an amount of 15,000 at the beginning of the year in a 10-year period. So that's step number 1, the timeline. Let's get the timeline sorted. Okay, let's let's use red. Okay, so we've got from year 0 all the way to year 10. That's what we are dealing with here. Right in the middle will be year 5. Let's annotate this timeline. And then we will have 1, 2, 3, 4. And then over here also 1, 2, 3, 4, 6, 7, 8, 9. All right, according to the question, we are told this is what happens. He deposits this amount of 15,000 rand into a bank account for a period of 10 years. The interest rate in the first 4 years is 6% per annum. The 6% per annum compounded monthly. Your small p here is 12. So it is for the first 4 years. It is 6% per annum. All right, 6% per annum. Let's make that green. 6% per annum. 6% per annum, and that is compounded monthly, meaning that your small p or m, if you prefer, will be 12. Next, let's see what happens to the rest of the investment period. For the next 6 years, the interest rate changes to 10% per annum, compounded semi-annually, meaning that it is compounded twice per annum, twice a year, meaning that your small p will be, or your m, meaning that that will be, so that is interest rate of 10% per annum, compounded semi-annually, that is 2 times per year. 8.2.1, well, we know that an amount of 15,000 rand was deposited at the beginning, so let's record that, so in case it is needed or important. Now question 8.2.1 says convert the nominal rates to annual effective rates. So let's start with the first one, the rate 1. Okay, we're given this one and it is 6% per annum. Okay, let's convert this into the effective rate. 1 plus I, which is effective, equals to 1 plus I m over m, all raised to the power of m. Now for 6%, we know that our little p, or m in this case, is 12 because it is compounded 12 times a year. Therefore, step number 2, so step number 1 is getting the correct formula to use, writing it out. You get a mark for this. Next step is substituting the values in the correct formula. So the IM is, so this is your IM. Your IM is 6%. So that will be 0.06. Always convert them to, and then your M is 12. Always convert them to decimal format. They are so much easier to work with. So therefore, I effective will be equals to 1 plus 0.06 over 12, all to the power of 12 minus 1, which is coming from that side. Minus 1, which is coming from the left-hand side. Now take out a calculator. Let's calculate this together. So that will be bracket 1 plus common fraction button 0.06, downward arrow 12, because it's compounded 12 times per year. Go out to the power of 12, right arrow minus 1, and that gives you an answer of 0.061677. 0.061778, blah blah blah. Well, we know we're supposed to round that off correct to 4 decimal places, so that will be 0.0618, meaning that therefore the effective interest rate here will be, therefore the effective interest rate will be, you simply take your comma 2 spots to the right, 1, 2, here it will land over here, so that will be 6.18%. Same story we do with the other one. All right, we've got I2 in this case is equal to 10% per annum. The second interest rate, 10% per annum. It's compounded twice a year, so that's 1 plus I effective equals to, in bracket 1 plus I m over m, all raised to the power of m. Like I said, always write the equation first that you're going to substitute into, and then next thing you substitute, you get 2 free marks for that. Therefore 1 plus I effective equals to, now we substitute 1 plus 0.10 over 2 because it's compounded twice a year, and we raise that to the power of 2. Next step, you take that 1 to the left, to the right hand side. The effective interest rate will be 1 plus 0.10 over 2, or raised to the power of 2 minus 1. Go back to the calculator, let's calculate that. So that will be 1 plus 0.10 over 2 raised to the power of 2 minus 1, and that will give us an answer of 0.1025. 0.1025, giving us an interest rate of 2 steps to the right, so that lands us over here, and that will be 10.25%. These are the effective interest rates. Next question, 8.2.2. Hence, use the effective interest rate, or otherwise calculate the future value of the savings at the end of the 10-year period. We're going to use both methods, and I'll show you how to use both methods to get answers. Now, the answers will be slightly different, but you will see exactly how and why. One level of accuracy will be different from the others, so let's go. 8.2.2. Supposed to find the final amount with this interest rate. Okay, so method 1. In method 1, we're going to use the method where we take the information raw as it is and use it to find the final amount with the compounding in place. So that will be the amount invested at the beginning of the year is 15,000. You can go back to the question if you want us to, but you've already seen that question a couple of times. So that is 15,000. In the first 4 years, the interest rate is 6% per annum compounded monthly. So that will be 1 plus that interest rate of 6%, 0.06 over 12, raised to the power of, it's for 4 years. And we multiply that 4 years by the number of times we compound that in that year, and that is 12. And then the next one will be 10%, and this 10% will be effective for 6 years. So that will be 0.10 over 2 to the power of 6 times 2. That is the number of times it is compounded in that 10%. Now we take a calculator, so we go 15,000, 15,000, in bracket 1 plus common fraction button 0.06, downward arrow 12, right arrow, x to the power of box, and that is 4 times 12, right arrow, open bracket 1 plus common fraction button 0.10, downward arrow 2 to compound it twice, right arrow, x to the power of box. Then that is 6 years multiplied by 2 because it is compounded twice in a space of 1 year. And that gives us 34,224 rand and 24 cents. That's how you round it off correct to 2 decimals. So that's 34,224,24. Let's just double check. Correct. And that's how you round that off. So therefore, the investment will be worth 34,224 rand and 24 cents in 10 years. All right. That is method 2. Now let's use the other method where we don't take the raw information, but we first take the interest rate and then convert them from nominal to effective. So we're using the effective rate here. A equals to P in bracket 1 plus I all to the power of N. So instead of using the raw rate, we use the effective rates. So that will be 1 plus the effective rate for the first one, the 6% one, is 6.18. So that's 0.6. So that's 0.0618, and raised to the power of 4 because that is 4 years. We don't do any adjustments to the time because we've already calculated the effective interest rate. Now notice for both cases, if you want to see that the total number of years matches, that's 4 plus 6. Same story here as 4 plus 6, that gives us a total of 10 years. Take out a calculator, let's punch in the numbers. So that will be 15,000, 3 zeros, 15,000, open bracket, 1 plus 0, 0618, that will be the first one, and raised to the power of 4. Right arrow, open bracket, next one will be 1 plus 0, 1025, and that should be raised to the power of, let's raise that to the power of 6. And that gives us an answer of 34,239.99. We round that off to 40 rand. So 2434 240, 34 240, 0.00 when we round that off. So therefore, the investment will be worth 34,240 rand in 10 years, after 10 years. I'm sure you can notice the slight difference in terms of the final amount, because this first method is a whole lot more accurate than the second method, but that's what you get at the end of the day. Let's look at the last question. 8.2.3. The interest rate for the first 4 years remains 6% per annum compounded monthly. For the next 2 years, the interest rate is X% per annum compounded quarterly. For the last 4 years, the interest rate is X% per annum compounded semi-annually. If COSA receives 48,897 rand and 3 cents at the end of the 10-year period, determine the interest rate for the last 6 years. That is the value of X. So this one has a different timeline that we now work with. Okay, let's make this timeline purple. All right, purple, let's make it purple just for. So we've got a slightly different timeline here. That is 0, 10. We are still investing the same amount of 15,000 rand, that's a P. All right, in the middle, that will be 5 years. And then 1, 2, 3, 4. 1, 2, 3, 4. Let's annotate this. All right, now it's broken into 3 pieces. So the first piece is the first 4 years. There is the first 4 years. Let's change the color, make it yellow. All right, the first 4 years, we have an interest rate of 6% per annum. It's compounded monthly, so small p will be 12. There we have the interest rate of 6% per annum, and the small p is 12. And then the next, just for the next 2 years, the interest rate is X% per annum, compounded quarterly. So our small p here is 4. Compounded quarterly, our small p is 4. The next 2 years, interest rate of X% per annum. Interest rate X% per annum. It's compounded quarterly, so small p is 4. And then lastly, the last 4 years, the interest rate is X% per annum, compounded semi-annually, meaning twice a year. So small p will be 2. And that is X, same interest rate, just compounded differently. Interest rate is X% per annum, compounded semi-annually, which will be twice a year. So this is what we have. We still have that amount of 15,000 at the beginning, and then we also have a final amount. This is our final amount of A. We still have the same initial amount of 15,000. Big P is still 15,000 rand. Now we're supposed to calculate that interest rate somewhere along the line that we need to work with. So let's go. So this is what we have. 8.2.3. All right, we're looking for the interest rate, all right, which happens to be X in this case. We've got the final amount given. We've got the initial amount, it's given. We've got the number of years, the total number of years. Yes, the total number of years is 10. 10 years, it's given. And we're looking for the interest rate. All right, at the beginning of the year, so we're going to be using the compound increase formula. We don't have any extra deposits or withdrawals in this period, so it's only that deposit of 15,000 Rand at the beginning. So let's count that. It's only this deposit at the beginning of the year. So we have, all right, for the first 4 years, we have, okay, so therefore, the final amount, let's use the final amount. We've got the final amount given to us. That is 48,897 and 3 cents. 48,897. 48,897. 48,897 and 3 cents. That is equals to P is 15,000. This 15,000 is subjected to this interest rate. Let me remove. I'll take this to the far right. Okay, let's remove it all together. This interest rate, this amount is subjected to the first form of interest rate, 6% per annum, compounded monthly for 4 years, so that will be 4 times 12. The second one for 2 years, there, according to the timeline. The second interest rate for the next 2 years is compounded quarterly. It's X% per annum, compounded quarterly. So we've got X% per annum, that will be 1 plus X over 4 because it's compounded quarterly, and it is for 2 years. So for that 2 years, we'll multiply that by 2. Another one for the next 4 years, 1 plus its X, also compounded twice a year for the next. So the first one was 4 years, next was 2 years, and the last one is 4 years. So that will be 4 times 2. This is what we have. This is how you set it up. So next step is you divide both sides by everything that you can divide by. So this comes here under 48,897. Therefore, 48,897,03 is divided by 15,000 and that. So it is divided by 15,000. It's 1 plus 0,06 over 12 to the power of 4 times 12. And that is equals to everything on the right hand side. So that will be equals to 1 plus 2 times 4, that is 8. 1 plus x over 4 to the power of 8 times 1 plus x over 2, all to the power of still 8. 4 times 2 is also 8. So you have powers of different bases but with the same exponent, and that gives us what? Easy peasy. It gives us this whole thing. 1 plus x over 4 times 1 plus x over 2, all to the power of, using the rules of exponents, got x to the power of n times y to the power of n can be written as x times y, all raised to the same power of n. That's exactly what we did here. So that gives us the same story over here, 48,897,03 all over. Okay, that's all over 15,000 bracket 1 plus 0,06 over 12, and that is 4 times 12 is 48. Now in order to get this on its own, all right, this is equals to now this is equal to 1 plus x over 4 multiplied by 1 plus x over 2, right? In order to get rid of the power of 8, we must make sure that this is to the root 8. So we take the root of 8 on both sides. Okay, let me fix this. So that will be 1 plus x over 4 times 1 plus x over 2. So we make this the root of 8. That will be 48,897,03 over 15,000. 1 plus 0,06 to the power of 48. All right. Now what we do next is we fix this, multiply this out. Okay, that will be 1 times 1, that will be 1. Plus x over 2 plus x over 4. X over 2 plus x over 4 will give us all over 4. 2x plus x, which is 3x over 4. So that will be 3x over 4. Plus x over 4 times x over 2, that will be x squared over 8. That's what we have on the left hand side. I mean on the right hand side. And on the left hand side we have exactly this. So we go again. The 8th root of all of that. 48,897 rand 3 cents. 48,897 rand 3 cents over 15,000. 1 plus 0,06 over 12 raised to the power of 48. So it is the 8th root of that. So now what we do is we multiply throughout by 8. That will leave us with, therefore, 8 times all of that, root 8. All right, let's get that sorted. 48,897 rand and 3 cents over 15,000 in bracket 1 plus 0,06 all to divided by 12. Don't worry, I'm going to show you where we're going. And this is 48, sorry, to the power of 48. Yes, equals to, when we multiply this throughout by 8, that gives us 8 plus 2 times 3x, which is 6x. 8 plus 6x plus x squared. Please multiply that out just to verify and check for yourself. Now the calculator work comes into play. So therefore we'll have on the right hand side x squared plus 6x plus 8. It's still exactly the same thing. I just switched the order of the terms the way they come. Now we use the calculator. 8 times the 8th root of, here is the 8th root of, the 8th root of common fraction button, 48,897, 48,897 and 3 cents. That over 15,000 times in bracket 1 plus common fraction button 0,06 downward arrow 12 over 12, yes, all raised to the power of 48. Raised to the power of 48, and then we take this right arrow, take it outside, and that is equal to, it gives us 9,0000, which is obviously 9. Therefore on the left hand side all of this is 9, equals to that. So you take this quadratic equation and then sort it out. So you take the 9 to the right hand side, that becomes x squared plus 6x plus 8 minus 9. Just excuse the noise of the canines. That is x squared plus 6x minus 1. Now use the formula. Let's use the formula. Therefore x equals to minus b plus or minus square root of b squared minus 4ac all over 2a. Let's substitute. A equals to 1 minus b equals to 6 plus or minus square root of 6 squared. Let's fix that. 6 squared minus 4a is 1 and c is negative 1 all over 2 times 1. All over 2 times 1. Check out a calculator. Let's go. Common fraction button. Negative 6 plus square root of 6 squared minus 4 1 times negative 1, downward arrow, 2 times 1. Let's just double check. Correct. And that is equal to 0.162776660. So let's make that 5 digits so we can run it back. So that equals to 0, 162277, 162277. What is the other one? 660, and so on and so on. All right, or another one. Remember, it must be rounded off correct to 4 decimal places because we're dealing with an interest rate. Always make sure. And then to get the other one, you just go back to your calculator and exchange the plus over there for a minus and go equal to, and boom, you'll have your answer. Negative 6, 162277. Negative 6, 162277, blah blah blah. Now notice that the negative one will be invalid because we have to deal with a positive value here. So this is invalid, meaning that our interest rate is therefore x equals to, round this off correct to 4 decimals. So you go chop at number 4 and look at what happens after number 4, digit number 4. So we round it off to 1623, 0.1623, meaning that therefore the interest rate is 16.23%. That is the interest rate that got them that final answer. And we've come to the end of our question on the paper and the video. Thank you so much for watching. I'll see you in the next one. Have a nice one. Bye bye.